Hello friends, welcome to my sequel video of equilibration time. You are watching this video because you are working with the program and you need bit of theory to learn the program. So then this is the right video for you. So you need to go in my website, then don't really bother about searching or remembering the name. You could just search with autoclave, AUTOCLAVE, and then search, uh, and then you will find a list of blogs is appearing, and you looked this photo and click here, analyzing VHP cycle. Yes, and it will give you the explanations of you can skip this is the diagram how the basic vacuum cycle look like for the porous load, but today we will stay here to learn. So normally the program interface what you looked at in Cloudi, it's the actual representation of this chart, and if you remember I talk about T2 where we are zooming in our program, if you remember. So this is T2 focus, we are zooming in. So this T2 is nothing about this one. So if I talk about this graph, just look very carefully. I mentioned the numbers here. 121 degree, which is your set temperature. It doesn't mean you need to set your temperature as 121. It's only for the representation. I just kept for your understanding. So if your, just imagine if your exposure set temperature is 121, then your bandwidth is set plus 3 means 124, and this is 126. I will come why I have written this 126 as well. So you see three sensor here, S1, S2 and S3. Remember, S2 is your load sensor, which you imagine this is one of the coolest, like heavy load, porous or metallic load, and this is representing S2. S1 is your uh, reference temperature in the chamber, which is the coolest one, most probably the drain. S3 is above your test pack, so you can consider the distribution. And if you see these three lines how they are moving with the window of Plato. um, what is Plato? You could see here like starting and ending where you see the hump in your cycles. So normally the equilibrations plus the whole time, this is your complete Plato in your cycle. So the Plato ends where your cycles is getting dropped from after your exposure drop down, and Plato in where you start your equilibration time. So if you looked at this line represent your whole time, like the set point of your sterilization, and you see this is S1 is arriving quite early here, but still the the sensor within the load it's being delayed, and it's come up after a few minutes, few seconds. So this timing is shown as T2. So this is the equilibration timing, and after this equilibration time your T1 means that the delta of T1 means the drain temperature and the load temperature should to be within 2 degrees. So always remember this capital T represent the temperature and this small t represent the timing. So the delta T, the temperature difference between your drain and your load should be within 2 degrees after this equilibration. Then talk about next. This is your distribution, this is your drain. So distribution sensor is allow in, this is within 60 seconds of frame, it could go more than set plus 5 degree, it's allow. So that is the reason I mentioned 126. So 121 plus 5 degrees is 126. So this is the upper limit of your distribution sensor, and this is going beyond. So this is still acceptable within 60 degree. But you see, it's come up and then it's joined your band. So it is within the band, sterilization band. And this delta T, again, this is the temperature. This delta capital T3 is the difference between your drain and distribution. It should to be within 2 degree till the end of your cycle. So this is although a program on equilibration time, but I mentioned distribution, penetrations, and drain sensor, how it's work. So you remember, this is the band, this is I created just to show you the distribution sensor. This is the delta. If you remember my graph, I mentioned all those things. This delta also mentioned as delta of S1 and S3. When you see my graph, this delta mentioned as delta of S1 and S2. Again, you could able to see in my graph where you could see all those differences are mentioned. Look, you could see all the delta values here, and all are within 2 degree. And you see, this is the 60 second. This is the difference between the distribution and the drain temperature is allow maximum up to 5 degree in fast 60 seconds. So where you could see this hump here. So technically you see all the nomenclature mentioned in EN285 in the same way it mentioned here. So it's relatively very easy if you go and read this guidance. This graph is available in Intuit 5 and XZC, or you could able to read from my blog as well, and I show you how to access my blog. So then in that case, to working with the program is quite easy. Hopefully I could able to explain this graph quite well. One more thing, this T2 is 15 and 30 second, but just remember, it is respected to your sterilizer size. If it is less than 800, then 15. If it is more than 800, then 30. So that is the reason. So I kept couple of more clarification what you don't see in Intuit 5, but I keep it as it is just for your uh, understanding. So I mention everything, but you don't really see this red one in the actual into 5. This is, I just modified the graph just for better understanding. I think that's it. You could able to understand the process quite well. So follow us and follow my YouTube channel as well. And it take a lot of effort to explain and to make all those things. So follow me, comment on my LinkedIn, and try to encourage me. It's always helpful for me when I see your comment, when I see your engagements. It's always encouraging me to make this kind of videos. Thank you very much. Have a good day. Bye.